Good evening. We're going to start a review for Chapter 8, review questions for our next coming test, which is on Tuesday, April 10th. It will be covering sections 8.1, 8.2, 8.3, and 8.4, and then 8.6. 8.6 is the one that we just got done doing the last couple of days after break, and then 8.1 through 8.4 were what we did before break, and then we're reviewing that for today. So what I did was I'm going to break the videos up. I'm trying to get through 8.1 and 8.2 probably in this first video, and then 8.3 and 8.4 in the second one, and then 8.6 will be the third video. You can kind of do it at your own pace. The suggestion would be to watch the videos for 8.1 and 8.2, and then practice some of them off the review worksheet that I have, and then go to 8.3 and 8.4, watch some of the videos and tutorials for examples, and then do some of the examples on those in class. So basically this hour will be for you to get ready for your test in the upcoming class. So looking at 8.1 and 8.2, we basically just did operations within rational functions. So every single problem, whether it's multiplication, division, or addition and subtraction, which is going to be your expressions and functions page, your first step for everything needs to factor all the numerators to denominators completely. So get them down to be binomials as much as possible. Get them down to be lowest terms as much as possible. And do not do any canceling until the very end. So if we're multiplying two rational functions, and we're just going to multiply straight across. We're going to take numerator times numerator, denominator times denominator, and then do your simplifying, reducing, and state your restrictions. Keep in mind your restrictions is what makes the denominator equal to 0. So whatever's left in the denominator, set that equal to 0, and those are your excluded values. Those come in handy when it's 8.6. Those are values we cannot have. Now the only difference between multiplying and dividing is that dividing, we do the same exact first step. We factor all the numerator, we factor the denominators. It's just that now we multiply the reciprocal of the second fraction. And then you follow the multiplication rules. So really the division is the same thing as multiplying. We're just going to multiply by that reciprocal of the second fraction. And then 8.2 focused on addition and subtraction. I kind of give you a tutorial, and I feel like you guys have got a pretty good grasp on this. It's just a matter of recalling now. So the very first thing we do, besides factoring the numerator and denominator completely, if needed, I mean if they're both monomials, then we don't have to worry about that, is we need to find the common denominator, also known as the LCD. So it's that value that we just found in 8.6 that we multiplied everything by to cancel out the denominators. Well, now that's our common denominator throughout all of the rational functions. So as soon as you find that LCD, we're going to write the equivalent fractions by multiplying by the multiplier. That multiplier is what do you multiply the denominator by to make it look like the new LCD. So that's like saying if it's 1/3 plus 2/5, the common denominator is 15 here. Well, I need to multiply this 3 by a 5 and the 1 by a 5. So that's that multiplier that you're multiplying the top and bottom by to create the new equivalent fraction. So this would become 5/15. This one would become 6/15, allowing us to then add or subtract the numerators. The denominators do not change, only the numerators. And then we simplify and reduce. But if you find the LCD, this step is kind of null and void. So let's just kind of get into an example here. So first one, the operation is multiplication. So we're going to kind of take care of everything we have on the numerator. You can't simplify here. You can't simplify here. Here we got 3 of these. So I need to write this as 24g cubed over 5f squared times 10g to the third f to the third all over 8 g to the fifth f. So since we're multiplying, we're going to take top times top. So we're going to get 240 g to the 6th power and f to the third. All of that over 40 g to the 5th f to the third. And now from here, this is our simplifying step. So you're going to take these two numbers here, and we're just going to divide. 240 divided by 40, which is equivalent to 6. So you have 6 on top. You have 6 G's, 1 G, or 5 G's on the bottom, so therefore we have 1 G left over. And then the f of 3 are going to end up canceling. So my final answer then is simplified to be 6G. So again, because it's multiplying, we just take numerator times numerator. We had to do a little bit of a simplifying step by distributing that exponent. Not very often we have to do that. Another example. So now it's division. So it's the same concept, but the first fraction, the 80y to the 4th, will stay the same, over 49 z to the 5th, b to the 7th. And I'm going to times it by this new numerator now gets moved to the denominator. Or other way around, I should say. Denominator is going to move to the numerator. Numerator is going to move to the denominator. So it becomes 14 z to the 12th, v to the 5th. All of that divided by 25 y to the 5th. You've now created a division problem into a multiplication problem. So you do exactly what you just got done doing on the slide here before. So we're going to multiply tops, multiply bottoms, and then we'll simplify. So by doing that, I'm going to change the color here. I'm going to do a little bit of cross-reducing here. I'm going to say that this 49 is going to become 7. This 14 is going to become 2. Only reason I'm doing that is because 7 goes into both of those evenly. So I'm just going to do that reducing to kind of eliminate some of the division we have to do here. So I'm actually going to divide this by 5. So 25 divided by 5 is 5. 80 divided by 5 is going to be, let's see here, 80 divided by 5, so 1 would be 16. So I didn't do any cross dividing, I just did some cross reducing. So I'm going to get on top 2 times 16, which is 32, 7 times 5, 35. And just to reiterate, you do not have to do this reducing now. You could take 80 times 14, 49 times 25, and then reduce in the very end. So I'm going to get y to the 4th, z to the 12th, v to the 5th, z to the 5th, v to the 7th, v to the 5th. Or y to the 5th, sorry, v's and 5's. So now we're going to reduce. So we have 32 is my number over 35. Y with y, so we got 1 y left over. 12 z's and 5 z's gives us 7 z's on top, and then gives us v squared on the bottom. So my final answer then would be 32z to the 7th over 35y v squared. Orders of the variables do not matter. You know when you're done when you only have 1 z, 1 y, 1 v, one single variable. Now, those are all monomials. So the same process goes with binomials. The only thing is we got to factor. So I'm going to factor the numerator. Factors of 24 that differ by 5 would be 8 and 3. We're going to go w. This would be plus 3, w minus 8, all over w plus 1 times w minus 7 times w plus 1 would be this factor. So this one factors to this one factors to that. All of that divided by w plus 3 and w plus 1. So a nice healthy habit that I like to do just to kind of keep things organized is that if I see a binomial, I'm putting these in parentheses right away. Knowing that I can't cross off the w's, I can't reduce the 3's, I can't cross out the w here, and knowing it, the only way I can cancel is if this is exactly the same as something on top. So since we multiply, this becomes one huge fraction bar. So I can cross this out, cross that out. I can cross out the w plus 3's, the w plus 3's, leaving me w minus 8 all times w minus 7. I'm done. All of that over 1. Everything in the denominator canceled, so my expression would be w minus 8 times w minus 7. So the only difference between the first problem was monomials. Same idea. We put things that are common together. The only difference is with binomials is that they have to be exactly the same in order to cancel. So make these smaller. Never make expressions bigger. So do not FOIL when you are simplifying, when you are multiplying or dividing. The whole point of simplifying is to reduce, get it down to smallest terms. Let's look at the last one for this 8.2. Because we need to factor the top. So factoring 16a squared, 40a plus 25 factors to be 4a plus 5, 4a plus 5. Factoring the bottom, it's going to factor to 3a plus 2 and a minus 4 times, I'm going to go ahead and move this one to the denominator. So I'm going to move 4a plus 5 to the denominator because now we're changing division to a multiplication. And then that factor in this one on top becomes a minus 4 times a minus 4. So again, division becomes multiplication. We factored, put this in parentheses. And now look to see what's in common. What are we able to cross off? Well, we're able to cross off 4a plus 5, 4a plus 5, and a minus 4, and a minus 4, leaving in the numerator 4a plus 5 all over a minus 4, divided by 3a plus 2. So in this expression, we got a denominator now. So if we were to solve or we're able to look for the values, or I asked what are the domain values for this function, you're going to say all real numbers except x cannot equal negative 2/3. These are the values that cannot plug in here because we're not able to divide by 0. I can plug in 4, I can plug in 2, 3, 8, all those values and get something out. It's just that if I plug in negative 2/3 into a here and a in the bottom, we're going to end up dividing by 0, which is our domain restriction. So that's one of our answers we are not allowed to have. Now we'll start the next video will be for 8.1. So this will be where the video will stop for today, or for this part 1 on 8.2, simplifying rational functions when it deals with multiplication and division.